Welcome to AI in Plainsight, the computer vision podcast where we chat with vision AI pros to discuss the latest use cases and applications while exploring the exciting possibilities of enterprise computer vision. I'm Ben Glace, and today we're taking a deep dive into oceans. Oceans cover 70% of our planet, house around 80% of its animal life, and they've absorbed nearly 90% of the heat from carbon emissions that contribute to climate change. Though it's essential to human life and the health of the planet, the world beneath the ocean surface is relatively little explored. The emerging blue economy aims to boost understanding and promote responsible stewardship over all of the world's waterways for more innovative businesses and a cleaner planet. Industries within the sector, which is expected to reach $3 trillion in total value by 2030, include marine energy and aquaculture. MarineSitu, a new Plainsight partner, offers submersible monitoring technology to enterprises in these industries and more, helping to protect vulnerable ecosystems while maximizing the value of underwater resources. Today we're joined by James Joslin, MarineSitu's president and principal engineer, as well as engineers and fellow co-founders Paul Murphy and Mitchell Scott to kick off a three-part conversation. How's it going, everybody?
Awesome. Thanks. It's great to be here.
Going good. Thanks for having us.
Yeah, thank you for having us.
Awesome. Yeah, thanks for joining us, guys. So to start, I was hoping you could tell us a little bit about your professional backgrounds and what brought you all to creating MarineSitu. James, if you want to take the first response.
Yeah, happy to. So I have a PhD in mechanical engineering from the University of Washington, and I went back to school to get my PhD because I wanted to get into renewable energy, and I always knew I wanted to found my own company. And before that, I worked for a group called Sea Education Association out of Woods Hole, Massachusetts, working on tall ships, sailing, and teaching college students about marine engineering. And then I went to work for a product design firm in San Francisco for about a year and a half. And I got my hands dirty, basically developing new products with a small group of really industrious engineers. And when I went back to school, I knew I wanted to find something that combined those different aspects. My interest in renewable energy, as well as background in marine engineering and product design. Paul, you want to give us some of your background?
Sure, yeah. I also have a background in mechanical engineering from my undergraduate days. And when I was in college, did a lot of audio recording and played in bands and such, and knew I wanted to go to grad school and kind of learn to do something that, like James, would be helpful to the environment, to the world in some way. And found this program, the same lab that James was already working in, where I could do acoustics research, underwater acoustics measurements of marine energy devices. And so kind of hit a couple bases, still kind of do some recording and do some science and hopefully help out a little bit. And so I went and got a master's degree at UW and worked alongside James a little bit, and then kind of continued working on projects there ever since until the company was founded and started working full-time with MarineSitu.
Yeah, similarly, my background started in mechanical engineering. I went to Washington State University for mechanical engineering. And towards the end of my bachelor's, I became really interested in robotics. So I stayed on for a graduate program as well. And in that program, I became really interested in computer vision. So after I finished grad school, I knew I wanted to do something involving the perception space. And when I was younger, I was really interested in the marine space. I used to do a lot of boating when I was younger. So I found a lab at the University of Washington, the Applied Physics Lab, that kind of focused on marine engineering. And I found a group there that was really interested in marine perception. So my background the last 4 to 5 years has focused on this somewhat niche field of underwater perception and things of that nature. So in that lab, that's where I met James and Paul, and we've been working together ever since.
So you've alluded to how the team came together, but how did MarineSitu get started in earnest?
Yeah, so as we alluded to, we're a spin-off company from the University of Washington, and in particular from a department called the Applied Physics Lab. And the Applied Physics Lab is kind of a special research institute at the university where we have lots of experience, basically going back many decades, working with the U.S. Navy, which really specializes the group in ocean engineering and developing underwater solutions for very challenging problems. And in particular, we all started working with this group really to get involved with this growing marine energy space that needed solutions to do underwater monitoring in very harsh and complex environments. So if you have a tidal turbine or wave energy converter, basically, and you want to know what its environmental impacts are, you need to be able to put instrumentation underwater for long periods of time and collect data basically continuously to capture very rare events. And so that's where the technology that we've been developing all got started. It was trying to monitor in these really harsh, complex marine environments for long periods of time. And as I mentioned, I knew when I was going back to grad school, I wanted to start a company. And I looked for research projects that had potential to do that. And in particular, the underwater monitoring tools were something that I saw as basically an essential piece to this growing new industry. And since then, basically, we got to, well, in my graduate research, I got to spend about 5 years developing a new technology that could answer some of these really complex monitoring questions. But even then, it basically, when I finished my PhD, the technology wasn't quite ready yet. And so we've had this relatively slow start where we all worked at the applied physics lab and had these kind of comfortable jobs to work from while slowly getting the company off the ground. And in the last couple of years, we've really seen a lot of momentum. Our technology is reaching a point where it's been demonstrated for long periods of time in these harsh marine environments, and it's really ready kind of for this commercialization push that we've been making over the last couple of years. In addition to Paul and Mitchell, we've got a number of different collaborators still at the university and in the area that we work with on a regular basis. But we've tried to keep the team relatively small and simple between Paul, Mitchell, and myself.
So could you tell us a little bit about what the actual hardware looks like? What does the deliverable that MarineSitu puts out into the world look like?
Yeah, so initially the system that we developed with the university, we called the Adaptable Monitoring Package, or AMP. And we called it that because to monitor these new underwater systems like tidal turbines and wave energy converters, there's a lot of uncertainty. People don't really know what they want to be monitoring for yet. And that's still being developed by both the developers and the regulators. And so we basically wanted a package that could easily accommodate a wide range of different types of instruments. But we knew one of the main things that was going to be needed was optical cameras. And so the package itself can basically allow you to plug in all these different instruments together and get them to work well together. But as a company, what we focused on initially was the optical side of things. So we developed a very low cost and user-friendly optical monitoring system that is basically a piecemeal camera system where you can take 1 or 2 cameras and up to 8 lights and synchronize them, put them all in a single package together and control them all together in a way that gives you basically the highest quality of data. In addition to that, the platform can basically take imaging sonars and hydrophones and other water quality monitoring instruments that allow you to understand more about what's happening in the environment than just what you can see optically. So yeah, we've basically started off with this underwater camera system, but we're basically expanding the platform to include all of the custom elements and software that have been developed for the AMP at the University of Washington.
So it sounds like this is a pretty unique technology, especially when you think about the whole package that you're ultimately delivering. Is this comparable to anything else in the industry or in the blue economy as it stands today?
So there are a lot of other underwater cameras and sonars and basically individual instruments. And there are a couple of people that have developed a similar integration hub that allows you to tie all these instruments together. But this system is by far the most demonstrated full package that is out there. So in general, these systems are pretty expensive to build. And so for that reason, a lot of them or the only things that are out there that are even comparable are research projects. And we've been basically, as a company, focusing on how to lower the costs and make these systems and the data processing and data management affordable to industries like marine energy, where the cost of this environmental monitoring, it can't be so high that it prevents the technology from being demonstrated. So that's been a key focus of ours. The other thing that is unique about our technology is that it was specifically developed for long-term deployments. So a lot of underwater cameras and things like that that are developed for marine applications are meant to go on underwater vehicles and in places where they come up to the surface every couple hours and they can get hosed off. And you're not worried about things like biofouling or corrosion as much as you would be when you want to put it out for years on end. So we've paid specific attention to eliminating dissimilar metal contact and providing anti-fouling solutions for all of our instruments that allow them to operate for long periods of time underwater without any issue.
And I know you've talked about cost being one area that's been a challenge for deploying solutions like these in the past. What about when it comes to expertise? I know you talked about how the submersibles that you're creating are more than just a camera. At the end of the day, it's more of a package that can do a lot of things. Do you see this as sort of helping lower the learning curve to using that data?
Yeah, that's definitely been one of the key focuses as well, is making this relatively user-friendly technology. So a lot of people in this area, developers in marine energy or other blue economy applications, are not experts in acoustics or on machine vision. They understand their field of developing a tidal turbine or a wave energy converter, but they shouldn't have to understand how to do underwater monitoring of those systems. And so that's definitely what we see as bringing to the table as well for all these different projects, is an expertise in these different instrumentation systems and how you get the best quality data from them.
Thanks for listening to part one of my conversation with the co-founders of MarineSitu, and thanks again to James Joslin, Paul Murphy, and Mitchell Scott for joining me. Stay tuned for the next episode of AI in Plainsight, where we'll explore some of the exciting blue economy projects MarineSitu has supported.